Hello, this is Tony Nichols, co-founder and Chief Technical Officer of Great Ideas. And in this course on enterprise architecture, in the application architecture domain, we're going to do a presentation now on dynamic page generation and why we think dynamic page generation is a great way to eliminate the majority of the CRUD code in an application. So the scope of this particular video, we're going to look at why do we use dynamic page generation in Great Ideas, and particularly why is it a central element of the trellispark framework. We're going to be looking at what a form definition is and how we can use that to generate pages on the fly. We'll also have a look at how do we secure the user experience, and then how do we take our dynamic page generation and use this in an omni-channel user experience. And finally, we'll discuss how dynamic page generation impacts the sustainability of our corporate applications. So first of all, let's consider why we want to use dynamic page generation in the first place. So when we get down to looking at the majority of applications that use record data, essentially most of that record data is typically presented to users in a form. So let's have a look at what a typical form looks like. So this is a typical form rendered within the trellispark framework. We can see that the rendering has some framework around it, so things like headers, navigation, some basic send receive generic functionality, but essentially the majority of the form is rendered in a sequence of tabs, and each of these tabs has a sequence of fields and tables, and what we're seeing here is essentially a user experience for a record. In this case, it's the form definition for a client, spread out on a two-dimensional surface, broken up into a number of tabs. Each tab has a number of rows, and each row has a number of fields. So basically, a record can be rendered as a two-dimensional form across tabs, rows, and fields. Now, forms basically have a lot of generic functions. So essentially, all of the CRUD functionality, the create, read, update, delete of record data, is common irrespective of what sort of record we're looking at, whether it's a client record, a customer record, or whatever. So one of the things that we have as common functionality on pretty much all of the forms we ever build is an ability to create, read, update, and delete record data. The other thing we need to consider from a user experience perspective is security. So the questions there are related to what users can see and do with the record data that we have on display. And we also want to look at the life cycle of record data. What is the life cycle of a record? When we're looking, for example, at a customer order, we might have the order in a draft state, a submitted state, a approved state, a fulfillment state, and a completed state. So we want to look at the life cycle of record data, and then as we evolve the record over time, then the user is going to be interacting with the record, and we're going to be calling actions and workflow on the record. So if we have an order, we're going to push it through a sequence of fulfillment steps. Now, what we're looking at in this presentation is how do dynamic page builders enable us to eliminate custom forms. So in many traditional applications, if I had a customer record and an order line record and an invoice record and an invoice line record, I might have several forms, one for customer, one for order line, and so on. So one thing that we're looking at doing with dynamic page builders is essentially eliminating all of those custom forms. So one thing you may have seen with no-code, low-code solutions is that the forms aren't actually eliminated. The forms still exist, and you interact with them through a UX creation mechanism where we're dragging and dropping fields onto a control surface. But in the background, the code to drive that form is still being created. What we're looking with dynamic page generation is to completely eliminate all of that custom code as well. So essentially, there isn't a customer form or an order form or an invoice form. There's just a generic instance form which can render any form of information to any user. So essentially what we're doing is saying, look, you know what, our record data is already in data agnostic storage. So we've got an XML representation or a JSON version of the record. So if we have got a data agnostic store of information, can we combine that with a form definition in such a way that when we load that page, we can take the data agnostic storage format, the form definition, and actually render a page dynamically on the fly. And if we can do that, and we eliminate all of these custom forms, then we've significantly reduced the effort, cost, time, and risk of both building the application and the user experience, but we've also significantly reduced the effort, cost, time, and risk of testing that user experience. So one of the cool things about using data agnostic services is the combination of both data agnostic record storage and the ideas around dynamic page generation are going to give us a substantial reduction in effort, cost, time, and risk. And at the same time, because we've also significantly reduced the amount of code in the solution, then we can also focus on improving the overall quality and robustness of the solution itself. So let's take a bit of a deep dive into dynamic page generation and how it all works. So the first question we have to answer is, what is a form definition? So the answer to this question is simply a form definition is going to completely define the user's experience of a form. It's going to say what the user can see and what the user can do with the information they can see. And clearly that's going to be determined by several factors. It will depend on the user's authorization. So what groups and teams the user is in will determine which records they can see. Which roles the user has determines how they can interact with any particular record. We also need to consider the current state of the record that's being displayed, and then any custom business rules that the business wants to imply over the top of that user experience. So let's have a look at what this might look like in practice. So this is the form definition for a Great Ideas client record. So when I look at my form definition for client, you can see I've broken down my form into a number of tabs. So I've got an overview tab, a contracts tab, a meetings tab, and so on. And I've got some basic information that says this is a client, the form type is concept, and there are a different range of form types that we might have within our application. And we'll discuss the purpose of some of these form types later in this presentation. And what is this particular form for? Are we allowed to copy it? Are we allowed to delete it? And so on. So there's a whole bunch of information that we want to gather to actually understand what the form is from a high level structural perspective. And some of these fields are dealing with how we're going to deal with the underlying data in the data REST system of record, and how we're going to use this for data migration and incoming data ingestion. And essentially what we're looking for in form definitions is expressing in detail exactly what this form is going to look like and how users can interact with it. So at the highest level of the form, what we're going to want to have a look at is some form permissions. So when we're considering form permissions, what we want to look at is what role does the user have to be able to interact with this form? So if I want the user to be able to save records, do they have to be a customer? Do they have to be an executive? I might want to consider what the state of the form record is going to be for the user to have this functionality. At the level of the form, I need to know whether or not the user is allowed to save data or delete data on this form. So when we consider permissions at an overarching record level, then we need to know whether the user can save or delete these records, and whether or not the user can save them only if they have specific roles or if the object is in a specific state. And again, there's a whole bunch of additional things that can be going on here, but essentially what we're looking at here is we want to be able to say for this record type, if the user's looking at this form, this is what they're allowed to do. So this is the can do. Permissions are what can you do based on your role, your state, and potentially any custom business logic that we want to specify as a business rule to say whether or not this user matches these permissions and so can therefore save this record. So I've identified on this record a bunch of tabs. So on any of these individual tabs, then again, I might also want to have basically a set of permissions to say, well, when the user looks at this tab, can they see it? Is this tab going to be visible to the user, yes or no? So again, I want to be able to check by the roles that the user has, the state of the object, and potentially some custom T-SQL to understand whether a user can even see a tab on this particular form. So this again is another example of what the user can do. And as you can see, right, this pattern is going to be common, right? Depending on the role, depending on the object state, depending on custom business rule executed through a T-SQL stored procedure, we can determine whether or not a user can save changes to a record, can delete a record, can see tabs on the record, and we can extend this down into the next level. So within the user experience, what we're displaying, as we've identified, is a set of rows. So here's the row numbers and field positions within the row. And then we can specify some XML element information to say, where is this field being stored in the X element, and then other information that relates to the display of the field. So for example, I'm going to have a client ID field, and that client ID field will have a label that says client ID, it's been declared of a counter field type, and I've got a whole bunch of information related to that field that will display how that field will be rendered or calculated within the application as a whole. And again, on each individual field, we can then specify permissions, and permissions again follow this common pattern, right, where we're looking at what is the roles of the user, what are the states of the object. Can the user even see the field? If the field can be seen, is it a required field or not? Can the user modify the contents of the field? If the field is a table field, so a list of things, is the user allowed to click on those rows? So as you can see, there's a lot of fine-grained control that we can put in the data configuration that determines what the display of the information is. And all of the screens that you've seen so far in this presentation are all using one common generic page builder. So you can imagine, all right, there's a tremendous amount of flexibility in determining what the experience looks like. So as we said, a form definition is going to completely define the user's experience of a form. And if you can do all of that in data, then you don't need to express any of that in code. So I don't need to build a separate form for my customer, for my client, for my order, for my invoice. I'm going to modify everything related to the form definition and the user experience of that form definition in data. So what I'm really going to write is essentially a dynamic page generation function that's going to be able to display any sort of data to any user, ultimately across any platform, any channel. So let's start drilling into this again a little bit deeper. So as we've already seen, a form is divided into a set of tabs. Each tab has a set of rows. Each row has a set of fields. Let's have a look at that in code. So here is some sample code for you to look at. This code is available for you to download on the greatideas.com website, and there's a bunch of documentation that describes this functionality in detail in the TrellisPark Academy. The entry point to this WASM website is essentially this index razor page here, and what we're doing in this particular model is we're using Azure Active Directory B2B authentication. So essentially this is the B2B authentication that will validate that I am Tony Nichols and I am employed by greatideas.com. So this is giving me a user account, and then I'm going to see a list of workspaces, and then I'm going to be able to go in and have a look at those workspaces. So let's have a look at our dynamic page building code. So essentially, our Blazor application has only got one page, this instance page, and this instance page is laying out the navigation framework, and it's creating an instance builder, and it's putting a header and a footer at the bottom of the page. So this one component is actually laying out the entire framework for all of the pages you've been looking at so far. If we open up our instance builder, you can see again that our instance builder is structuring the elements inside the page, and it's rendering a command bar and a toolbar. So let's quickly have a look at this so far. So this is the command bar, this grey bar here, and then this tab bar here is where we're actually laying out our tabs, our rows, and our fields. And all of this is the header, this down here is the footer, and then everything over here is our navigation pane. Okay, so you can see one of the really cool things about Blazor and WASM is it's really clean, it's really simple to use, and the way that we use these components and the hierarchy of these components gives us tremendous flexibility in building out and customizing user experience. So let's drill into this. We've said that the tab bar is the important bit because a form is broken up into a sequence of tabs. So if I open up my tab bar, okay, we can see that for each tab on the tab bar, we're going to render a set of rows. So essentially this is the code that's basically rendering the rows. And then each row here, we're laying out essentially a table within the page, and then we're defining a set of fields on each row, and we're naming the fields left, 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 right, left, and so on. So essentially we have a record, a form definition. Form definition defines a set of tabs. Each tab defines a set of rows. Each rows basically has a set of fields. And there's a ton of different ways we can customize every single element of this as we go through. And again, there is topics on the TrellisPark Academy that shows you in detail exactly how to do this. But the key elements to take away here is we have the dynamic page, the instance page. It's rendering an instance builder. Within the instance builder, we're rendering a command bar and a tab bar. The tab bar is rendering a set of rows, and each row is rendering a set of fields. And then up here, we have the display of the individual fields. So here we have the generic field component. So what's happening inside here is we're saying, what kind of field is this? Right? If this is a string, render me a string. If this is a numeric field, so a number, an integer, a double, render me a numeric. We don't just have to render simple elements, right? So for example, I could render a document, a Power BI report. I can render Stripe payment information. I can do a whole bunch of drop-down fields. Essentially, I can render in any field any type of user experience I want to build. So if it's simple, like say a numeric, I may just want to look at the numeric type. Is this currency, a decimal, a slider, and then render that control as a simple user experience element. If it's something more complicated like a document, then again, I'm going to want to be able to select which document I want to display, and then I'm going to want to be able to pull down that document and render it on the page. And potentially in this particular case, I might want to be able to download this document as a PDF or print the PDF directly. So in this particular case, the field is trying to render a document, and you can see that there's some baseline user experience here, but there's also a bunch of code in the background that's actually doing the rendering of the document. It's going to the database, it's figuring out, does the user have access to this document? If they have access to the document, go and get that information and then bring it back and render it. And again, all of this is described in detail on the greatideas.com website and in the Trellispark Academy. So I'm not going to go into a ton of detail on this code here. What I'm trying to convey here is the simplicity of a Blazor WASM approach to actually structuring a dynamic page builder and the sorts of flexibility that you get right out of the box by using this sort of technology. So the next cool thing about this is all of this is now encapsulated inside a series of simple projects which are available either in source code. So all of the source code for these projects is available on our greatideas.com website, and all of the actual user experience components and services and shared library types and stuff like that are all available as NuGet packages, so you can download these and actually use them in your build. And the really cool thing about this that I find absolutely fascinating is that I can take these components that I've built here in Blazor, and I can build a hybrid MAUI solution, so I can use exactly the same code here, not only on the website for the WASM Blazor, but also on devices using a hybrid MAUI Blazor solution. So as we've just looked at in terms of what the user can see, just summarizing quickly again, forms are divided into a set of tabs. Each tab has a set of rows, each row has a set of fields. Each of the rows, fields, and tabs has a set of permissions that determine whether the user can even see the tab, row, or field, and in the case of fields, whether the user is allowed to edit the field information or interact with the field information or not. And essentially, each field is going to implement a single aspect of the user experience for the record data. So I'm going to display this numeric value. I'm going to display this document. Now, these Blazor components are completely open-ended. You can mash them up with other data. So for example, I could have an address component that does an integration with Google Maps. So there's no limitation on what you can put in a field and the complexity of the information that you can encapsulate within the record XML element that will be rendered by that field. And every single field implementation essentially is completely generic, and its function is totally limited by the record data we want to display right now and the form definition that will control that user experience. So that's what the user can see. Now, what about what the user can actually do? Well, covered in our form definition, there's a couple of other things that we might want to play with our records. Okay, so forms are essentially going to display a set of commands that we can use to initiate action against the record. So what does this mean? There will be a command bar where the user can actually say, execute this command on this record. So let's have a look at what that might look like. So if I'm here on this Great Ideas functionality record, you can see that the command bar is visible and enabled, and I can use it to initiate a command. So I can clear application state, I can generate SQL for this particular command, I can refresh configuration lists within the application. So essentially within the user experience, I can execute commands or events at this level against the record I'm looking at. So what does that mean? Does that mean that this command code is embedded in the form? And the answer to that question is clearly going to be no. One of the key elements of data agnostic services is a complete separation of concerns. So rendering the user experience and saying that at this point, given the user's roles, the state of the object, and all of the custom rules, here is the list of commands that the user can initiate action against the record with. But the actual action is not in the user experience. We've separated that out into the data in action service area. So we'll do a whole bunch of deep dive videos around that. And again, ton of information available on the greatideas.com website and the Trellispark Academy. But essentially what we're saying is the user experience is saying there is a command called refresh config lists available at this point in time. And if the user chooses to click that command to action it, then what's going to happen is that the presentation has initiated the action, but it doesn't do anything about it. That action request is sent to a completely separate service that will actually execute the action on the record. And then when that action completes, successfully or failing, we're going to get a result back, say this action was successful or this action failed, and then we're going to refresh the user experience, because executing the command may change the state of the object, or it may change the user experience of the object in some way for this particular user. So essentially we have a complete separation of concerns. The user experience displays a command button that says, hey, if you push this button, it will do X. And then when you push the button X, then the user experience goes to a data in action service and said, the user clicked button X on this record. Can you go and do that action? Tell me what happened. and then we'll get a response back from the action that says, yep, it worked, or no, it failed, and then we'll refresh our user experience. So that's commands. Commands are simple. But there's something else going on here, right? We also have this idea of state changes that we want to talk about. So similar to events, essentially a subset of commands are this idea of events. And the point is that an event is describing an event that will change the record state. So let's have a look at record states and how we are recording record state in the UX. So whenever we declare a new concept within the data model, we're also given the option of declaring workflow. So here in the workflow tab, we can see that we have a list of allowed states and allowed events. And then when we have an initial state and an event, we end up in a final state. So whenever we create a new object, we're going to have a default state. So in this particular case, the default state of the client object is prospect. So here is prospect as an allowed state. And if I activate a prospect, then it goes into the active state. So again, we have a lot of potential complexity, and there are videos in greatideas.com and the trellispark Academy that explain this in detail and show you some of the underlying WASM implementation of this. But essentially what we're saying is that if we are in the prospect state, we will provide an event that says activate, and we'll end up in the active state if everything goes well. So we have a ton of flexibility here. So we have a gate stored procedure to say, you know what, if we want to just check, right, that the state transition is actually allowed for this user. So for example, let's say it's an order and we want to approve the order. As a baseline CSR, I might only be able to approve orders up to say $10,000. If the order is like $1 million, then I'm not allowed to approve it. So although I've got initial state, the initial state may be submitted and approved and it goes into an approved state, if I don't have the authority to approve an order over $10,000, then the gate store procedure would say, you know what, you can't even see this because you don't have the authority to do anything with it. The other thing we can do is tag it against the user roles. So if I don't have the CSR role, I can't approve an order. And we've also added hooks in here for code to happen before we change the state, after we change the state. And then the other thing that we need to consider is, does the state transition on this object cascade to lower level objects? So if I have an order that I'm moving from submitted to approved, do I need to change the state of the order lines so that I can begin fulfillment? So again, we have a bunch of detailed presentations and videos and material on the design and implementation of state transition diagrams. But the essential thing that we want to take out from an architecture perspective is it is possible to define a very complex modern state transition method in data that we can then apply through a common set of code to any instance of any object within the solution. And so from the perspective of what the user can do, we've talked about forms, displaying events that can be used to change the state of the record. When the user selects and clicks that, then we might want to cascade state change down onto descendant records. We're going to control this whole process using the state transition diagram mechanism we've just illustrated in this presentation. And the bottom line is, once that event command has completed and we have a result one way or the other, the user experience will refresh to say, well, the event happened, it was successful or it failed, and the state of the object has changed to this, and then anything else that was changed as a result of any of the store procedures or actions that occur as part of either the before change event processing, the after change event processing. And if, for example, it was an order and I have a bunch of order lines on a table, then we will see that the status of the order lines potentially has changed as well. So the form definition has completely defined both the life cycle of the record and the user experience of the record. So the next obvious question is, how do we secure this, right? We've just built this really powerful dynamic page generator, and we want to make sure that users are only actually seeing information that they're allowed to see. So essentially, we have two things that we need to worry about: authentication. So authentication is happening to validate a person's access to the environment, and then within the environment, authorization. So how does the user get to see the information within the databases that comprise the record storage? And we also want to make sure that these same rules are then applied across all of the data agnostic services. So if I say that this user is allowed to see this record and do this action to it, that's great, but it has to work on the data presentation in the dynamic page generation, and it has to equally apply to data in action. If I'm going to actually process a request against that information, I want to check that the user still has access to that record, that the user has access to that command, given the state of the record at the point where I'm processing the action. So I want to make sure that these security requirements in terms of authentication and authorization are consistent across all of the different data agnostic services. So let's quickly deep dive into see how we're going to implement that. So the first problem is authentication. So we are separating the concept of a user profile, a person, away from the concept of the workspaces that the user will operate on and the user accounts that they will use within the workspace. So an authentication provider is saying that Tony is really Tony and Alex is really Alex. Okay, so all the authentication provider is doing is saying, this is Tony, this is Alex. So we provide a bunch of authentication providers out of box. So we have a standalone authentication model where you would identify with, let's say, an email address and a password. We also support out of box right now Azure Active Directory, so B2B and B2C solutions, and we have extracted the authentication provider into its own WASM website. So the only thing in a WASM website is actually the authentication. And then below the authentication, what you want to be executing is your dynamic page builder. Okay, so there's no reason to build a whole standalone website with all of your page generation inside there and then do the same thing again for Azure Active Directory B2B and have all of the code repeated there and do it again for B2C or Okta or however other authentication providers you want. Blazor WASM gives us this really cool ability to actually take all of those components, put them into a shared project as a class library, and then reuse that code across multiple authentication providers across omni-channel. So this is really cool. So given that I've identified Tony and Alex uniquely, next we need to say, within this environment, if you're Tony, what data can you see? So within an environment, we recommend that you create workspaces around sets of data. So a workspace is purely a security context, a boundary. The only people that can access records within the workspace are the users of the workspace. So if you don't have a user account within a workspace, you can't see any data inside the workspace. So essentially in this example here, Tony has a user identity in the server owner workspace. So Tony is going to be able to see records in the server owner workspace. The Alex user has a user record in the server owner workspace. So Alex can see records inside server owner, but Alex also has two user identities inside the customer workspace. Now, the reason Alex may have more than one identity in the customer workspace is that she might be executing different roles. So she might be in there as, let's say, a customer administrator for the workspace as a whole, for the GTA, but she may also be there as an administrator for, let's say, Ontario in general. But she isn't in there with access to Canada as a country or the USA or Europe. So essentially what you might have is Alex has a single user profile. So this green thing here is Alex's user profile, and Alex's user profile, once she's authenticated as Alex, gives her single sign-on to multiple workspaces using multiple roles or entry points. So this gives us a really flexible way of authenticating each of the individual people who have access to an environment and then really locking down the data to say, well, you have to have access in a workspace as a user of the workspace to see any of the records of the workspace. So once you have a user account inside a workspace, then we have our two questions. Okay, what can the user see and what can the user do? So when we're considering what you can see, essentially it's going to come down to two things. It's going to be what groups or teams the user has access to, and essentially every record in the database will be authenticated against every user trying to access it. So if you think about it, a record has an instance GUID in the instances table maps to one or more instance access records, and the user must have a record that says this user, either directly or through a group or team that they belong to, has access to this specific instance record. And again, the detail on this is contained in the TrellisparK Academy and inside the Great Ideas website. And it's quite intricate in terms of how you would actually want to do this, because the last thing you want is to put instance access records on every single record. So there's a whole bunch of cascade rules and things like that to bear in mind. But essentially what it guarantees at the end of the day is that when a user tries to access a record and read a record, they must be given direct access to either the record itself or an ancestor of the record using the parent-child hierarchy. So the next thing to consider is what can the user actually do? So from a user doing something, they need access to a form definition that allows them to see the record in the first place. So essentially, the user apps is essentially going to allow them access to entry points. So either a portal or an application that says, here is a list of customers, here is a list of clients, here is a list of orders. So if the user doesn't have access to the portal or application, then they can't see the records that are controlled by that portal or application. Now, once the user has access to a record through an application, then we need to start considering, fine-grained functionality. So one of the major, granularity restrictions is the idea of a user role. So each user can be assigned 0 or more roles, and then given that the user has access to the form, as you've already seen through the permissions, that can then restrict visibility of tabs, of fields, can restrict whether they can read or update the fields and so on. So one of the things that's really limiting the granularity of what users can do with forms definitions is this idea of user roles. So this is, again, quite an interesting and easy concept to understand. And again, once you've implemented this in data, the code never changes. So when I declare whole new forms for whole new areas of functionality, let's say, for example, I want to make this into an insurance claims application, I can create a concept for an insurance policy. I can have an application that lists all of my insurance policies. I can define what the fields in the insurance policy are. I can define some user roles and so on. And all of this extension of the application is purely in data. All of the code that's powering this dynamic page builder is actually in the dynamic page builder itself. So as we've already touched on in a couple of places in this presentation, once you've got the idea of a dynamic page builder, the next question is, well, can we only do this on websites? And clearly the answer is no. All right. Once you've got the idea and technology around building a dynamic page builder, then you can create platform-specific versions of the page builder. So, for example, we use Blazor WASM for websites, and we're also looking to use MAUI hybrids with Blazor for native mobile applications like iOS and Android and tablets and desktops, etc. So the ideas around what can you do with a dynamic page builder, how to do it, is that I can take the data model that I built for my forms definition, and I can build a dynamic page builder that's going to display that record using this form definition on our WASM-based website. And now if I've also got a dynamic page builder that will take that same record data and that same form definition and render an equivalent experience on a tablet or a phone, that's it, job done. I've now gone omni-channel. I've gone from website to native application without having to build new records, without having to build new form definitions. I can just reuse that form definition across multiple platforms, and that's really good. Okay, so a key element of what we're doing here is that we now have an omni-channel capability. And what does that mean? Well, we put all of our record data and form definitions into the same data at rest record storage. So what this means is any user on any platform has real-time access to the latest version of any record and any form definition in the system. So if the user is interacting on a website and changes a record and refreshes the display on their Android application, we are guaranteed it's going to see the updated record information. If the user changes the form definition, let's say they add a new field or they remove a field or they add a new command on the website, and we refresh the page on the mobile application, that new field or command or event is now instantly available on that mobile application. I didn't need to ask the user to go to the App Store and download a new version of my app. It's already there. And this is huge when you think about it, because what this means is that when I push an update to form definitions across an environment, it immediately is synchronized across all of the platforms that use that environment. I don't have to go to app stores and download new versions of applications. I don't have to publish a new version of my application in an app store. Essentially, I'm using the same dynamic page builder on each platform, and I immediately take advantage of any changes to any form definitions. So the final question is, how does this impact sustainability? Well, as you'll have already taken away from a lot of the enterprise architecture videos that we do, when we think about sustainability, we're not just thinking about green. Okay, when we talk about sustainability at Great Ideas, we're thinking about how do we improve the lifecycle of applications over their entire DevOps lifecycle, from actually creating the application in the first place to running it for a decade or two, and then finally retiring it. So one of the really cool things about these platform-specific dynamic page builders is it means that we can absolutely focus on providing a high-quality user experience. So what we are building in the dynamic page builder is we are building the best possible user experience based on a data model. And in trellispark, obviously Great Ideas is doing this for you as an example, although clearly you can take the ideas and concepts from this presentation and build your own in a completely different technology. It's totally up to you. So the trellispark and the Great Ideas information that you can download will give you a really detailed how-to guide on how to do this. But the point is that all of the development efforts in building the page builder, we can focus on the quality of making sure that that page builder works efficiently and correctly at all times, that it fails safe, that it's secure. So our focus is not on trying to build 1,000 different forms for customers, orders, invoices, and then hoping that we manage to standardize the approach and hoping that the quality across those 1,000 forms is all correct. We're building one dynamic page builder. And the really cool thing is it's easy for us to take that dynamic page builder, throw it away, and building another one when new technology becomes available. So obviously Blazor wasn't around a couple of years ago. And if you looked at the Great Ideas technology 2 years ago, we were building on the .NET 4.72 framework, and we were using ASP for our web pages, and we had Xamarin Form Builders for our mobile devices. But as Blazor and hybrid MAUI becomes available, we can throw away our old dynamic page builders and re-implement with Blazor-based page builders, and it doesn't impact our clients at all. They've still got the same records, they've still got basically the same form definitions. All they've got now is a much better user experience. It looks nicer, it runs a lot faster. There's a huge bunch of usability enhancements that we implemented when we upgraded from our .NET 4 framework to our Blazor WASM framework. So this just underlines I didn't have to rewrite thousands of pages when I went from .NET Framework 4.7.2 to Blazor. I just rewrote the dynamic page builder technology. Now, cool thing about that is that once you've built that dynamic page builder, it's really easy to build and test. Right? So I'm building something that renders a sequence of tabs, a sequence of rows, a sequence of fields, and here's how my generic fields work. Test out that, make sure all that works. That is easy to do. And then when I want to build out 1,000 different concepts for customer, client, order line, invoice, I don't have to test and build and test all of that code. I can just say, well, you know what? I built and tested the page builder to use this format of form definition. And as long as I'm not changing the form definitions in structure, then that page builder is going to work. So I can now build out 1,000 or more different concepts and the user experience related to those. And there's nothing to actually test, and there's little, if any, code to write. So from a sustainability perspective, this makes it really easy to build and deploy these frameworks, makes it really easy for me to add extra concepts and change the way concepts work, add extra columns, change the labels, change the descriptive text, and so on. Okay, this makes it very, very simple for me to actually evolve the solutions that we're putting in place for our clients. As we've said all the way through this video, the Blazor WASM for web and the hybrid Blazor MAUI for devices is absolutely awesome modern technology. It makes life so much easier for us as developers and architects. And if you're not already using it, I strongly recommend that you have a look and see how it works. All of the code examples and things related to this particular course have all been developed using Blazor WASM. So all of the demos and the code we've looked at is the latest Microsoft technologies. All of that is available for free for you to download from the greatideas.com website, and all of the documentation related to the detailed design of this is in the Trellispark Academy. So net is, using form definitions, using page generation is going to be a significant reduction in cost, time, effort, and risk to develop, build, and test and deploy user experience. It's going to make it so much easier for you guys to maintain that over time. The other really cool thing about sustainability is it is actually green. Okay, so when we look at what we're doing with WASM WebAssembly, particularly when we deploy things for, say, websites or devices, all of the rendering of the client user experience is happening on the client's device. So we're making use of the fact that the client has already spent thousands of dollars in many cases on their laptop, on their phone, on their tablet. Okay, and we're using the processing power of the device to render the user experience. This means that I can significantly reduce my server-side infrastructure and the network overhead to get the data from the back-end systems of record in the record storage to the device, let the device render the user experience, controls the user interaction with that user experience, doing all of the validation checks on the client's device, and only when the client wants to actually save changes to the data do I then send the changes on that instance record from the device to the database, and then I can just re-render the page from the database. So what this means is that the combination of using data agnostic record storage with the idea of using data agnostic presentation using dynamic page builders means that I also have a significantly reduced server-side footprint, which again helps my green credentials.
To learn more about Great Ideas products and solutions, visit greatideas.com. That's great ideas with a Z.com. Thanks.